Okay, today we're going to continue with what we did yesterday, and we're going to be doing lesson 7.2. This is also using the graphing method, but today I'm going to show you a couple of new instances where you will see new things and know how to do this. Okay, so let's go ahead and jump right in, and we're going to do 3 examples again today, and then I'm going to talk to you about some vocabulary stuff with these problems. Okay, so example 1 says solve the system. And we have 2 equations. We have x plus y equals 3 and x plus y equals 7. Okay, so I'm going to draw this, a graph for this. Okay, and now I need to graph these 2 lines, just like we did yesterday. Now these are pretty easy ones to do t-charts with. If you want, you can do slope-intercept form with them. Let's do one each way. Okay, so the first one I'll do a t-chart for. I need x plus y to equal 3, so that would be like 1, 2, 2, 1, and 3, 0. Okay, I did easy ones, 1, 2, 3, because I knew that they would work and be easy. Okay, we don't want to end up with fractions, so if you choose a number and you're ending up with a fraction, then just choose a different number. Okay, so let's graph these. 1, 2 is here, 2, 1 is here, and 3, 0 is here. So I'm going to draw my line. Remember from last time that we have to be super careful in making sure that we hit through those points correctly. Okay, and I should be labeling these. So I'm going to go ahead and label these. I think yesterday I didn't label all of them. Okay, and then let's do the second one. Let's do it by, actually I'm going to erase that arrow. Let's do it by doing slope-intercept form. So I'm going to minus x, so I get y equals negative x plus 7. Okay, so that means, ooh, you know what? I don't want to do it that way because my graph isn't big enough. I didn't make it go up high enough to reach the y-intercept of 7. So let's just go back and do a t-chart on this one too. Okay, see, it's real easy. It doesn't matter which way you do it as long as you do it correctly. So this t-chart, I need x plus y to equal 7. So I'm going to try to pick some numbers that are actually on this graph because I only went up to 4. I should have gone a little bit higher. So 3, 4 would work on that. 4, 3 would work on that. And I don't have it quite to 5, but I think I can stretch it out a little bit. So I'll do 5, 2. So I'm going to go over here, erase this, and make my graph stretch just a little bit more. Okay, so I have 3, 4. So 1, 2, 3, 1, 2, 3, 4. I have 4, 3, and I have 5, 2. Okay, so I'm going to draw this line. Trying to be super careful. Okay, and this one is called x plus y equals 7. Okay, so do you see a problem here? Our problem is that to solve a system, solving the system, right, we need to be able to see where they cross. Well, do these 2 lines look like they are going to cross at any point? No, these are parallel lines, and so they will not ever cross, right? If my lines had looked like this, okay, then I could say, hey, these are going to cross eventually. I need to just keep drawing them with my ruler until they cross, right? But that's not what these green ones are. They're not ever going to cross because they are parallel lines. So my answer for this system is these are parallel lines, right? Parallel lines do not have an answer. So in order, how you will say that as your answer is you will say no solution, right? That's the same as no answer. A solution is an answer. And so this is my answer on here, is no solution. And then I'm going to, and then I'm going to box that because that's my answer. So if you get parallel lines as your answer, your answer is actually no solution because they don't ever cross. Okay, let's do a different example. Example 2. Okay, this one I want you to do on your own because it doesn't really have a funny thing like the first one did. Okay, solve the solution. We're going to have 2x plus y equals -4 and x minus 3y equals -9. So I want you to take your, figure out how to do this like you did yesterday. But this time you have me here, so after you finish solving it, we're going to go through it together. So you're going to make your graph, and you're going to graph your points and figure out where they cross, and then we're going to come back, okay? So go ahead and hit pause and find out the answers. Okay, you should be back now. So I am not going to do a T-chart on this because it is a little bit more difficult on this one than those other ones were. So instead, I'm going to change them to slope-intercept form. So I'm going to take this one, and I'm going to minus 2x from both sides. So I get y equals -2x plus -4, or I could put -4, right? Same thing. So now I'm going to graph this. I have a y-intercept of -4, and my graph did not go that far. So 1, 2, 3, 4. Okay, so I'm going to put a dot 1, 2, 3, 4 at -4. And then my slope is -2, so I'm going to go up 2 and to the left 1. Okay, up 2 and over 1. And so I'm going to put a couple points here because I really want to make sure that my graph is super straight. So if they cross, I can see exactly where they cross. Okay, so there's my first line. Now I'm going to do my next line. I'm going to use this equation for, right? So to solve that one, I'm just going to rewrite it over here so I can kind of do all my work. I'm going to minus x on both sides. That leaves me -3y equals -x minus 9. Now I'm going to divide by -3 on everything, right? So I get y equals 1/3 x plus 3. Okay, so if you did not get that, then you need to look back at your equation and see what you did wrong. Okay, always look at what you're doing. Look at these, every part of what I'm doing, and making sure that you did them exactly the same. If your graphs look different than mine, it's probably because your equations are different than mine. Okay, so check those things. And if you don't have the same equation, then look up here in my steps and see where you went wrong. Okay, so let's graph this. I have a y-intercept of 3, so I'm going to go 1, 2, 3 right there. And I have a slope of 1/3, which means I go up 1 and over 3. So right here. And then as I could do it again right here. Okay, or I could go down and over 3, which is right here. So now when I graph this one, okay, I can see, I should have written my equations on these. Oops. Trying to turn my thing to write better. And it's turning the whole screen. Okay. So where did they cross? They crossed right here. And that answer is -3, 2. And that's my answer. Okay, is -3, 2. Do not just leave it as a graph. I want you to actually write out the answer like this. Okay, so that one's just like yesterday. There's nothing new on that one. Just another showing you of a graph. Okay, but this next one, example 3, is our last example. And it is different. So we have x plus y equals 3. And I'm going to write the next one right next to it. 2x plus 2y equals 6. Okay, so I'm going to take this first one and change it in slope-intercept form. So I'm going to minus x on both sides, and I get y equals -x plus 3. Okay, let's graph that one. Okay, I'm going to, all these same colors driving my eyes a little crazy. So I'm going to make my graph black. And then I can graph in green. Okay, my y-intercept is 3. and my slope is -1. So I go up 1 into the left 1. And since my graph is going to run out of room if I keep going up, I'm going to go down. Okay. Okay, so I'm going to draw this line. Remember, being careful that I go through the right spots. And this is x plus y equals 3. Okay, now let's do our second one. So now I'm working on this one. I'm going to minus 2x from both sides. And I get 2y equals -2x plus 6. And I'm going to divide everything by 2. So I get y equals -1x, which is just -x, plus 3. Okay, so now I need to graph that one. But I want you to look before I graph that one. Look at the first one. What do you notice about both of these equations? They are the same thing. So if I were to go and graph this one right here, I'm going to do it in a different color. I would go graph y-intercept of 3, and then I would go -1 slope. So I would go up 1 into the left one, and then or down 1 into the right one. And look, I'm getting the same points. So this equation and this equation are the exact same equations, even though they don't look like it. But if I divided everything in this equation by 2, it would look exactly like this one. Okay, so what do we do when that happens? What do we do when we are graphing and we have the exact same equation? Well, my answer is all the points on that line are answers to both of these equations. So what we call that in, my graph is changing. What we call that in this is that it has infinite amount of answers. So sometimes in the book and other parts of the book, it will say your answer is infinite, right? Or might say infinite answers. But in today's homework, it will say entire line. So what's your answer? Or what's the solution? Everything. Everything on that line is a solution. Not just, I'm going to put this in red, not just this point or this point, but all the points. This half point and this third point, all of these points are all answers to both equations. So all we do instead is just say the entire line is my answer. And that's it. Those are the 3 situations you'll have today on homework. You will have a no solution where you get parallel lines. So remember, they do not have answers. You will have ones that have just 1 point, and that's your answer. Okay. And then you have ones where it has all these points, and the entire line is your answer. Okay, so a couple more things that they're going to ask you. And this is not in any test. I don't put this in any quizzes or any tests. But this is some of the things that they may ask you about. Okay, there's a little chart on page 278. Actually, I'm not going to go through it all because I don't ask you about this in any of your worksheets or things. So we're just going to leave it out. If you want to look at the table on that page, then you'll see some words like consistent and inconsistent, and then they have words like finite, infinite, infinite, none, all that stuff. We're not going to talk about a bunch of this stuff because, first of all, I think it confuses you too much. I'd rather you just get into the habit of learning the no solution, the one solution, and the infinite amount of solutions before we talk about consistent and inconsistent. Okay, so instead of having all that, when it tells you to do that in your homework, I want you to just leave it out. Okay, just leave out the consistent and inconsistent and just give me the answers like we did up here. Okay, and that's it for today.